dubbing using deep learning techniques, which was done by myself, Ganesh, Shanmukha Bhargav, and Nasima, under the supervision of Sanjarani ma'am. Yeah, we done this mini project in order to improve the dubbing of a person using some deep learning techniques. Basically, we are doing this with the reference of our first order form, model for image animation, which is a Fourier technique, where we use face of a person and we'll change the properties of the face of that person in order it to be accurate. But considering entire face of a person is it's a very high task. So in order to overcome that, we are just targeting the lips of a person. If in order it to be perfect, so for that purpose, we have done a project in order to improve that lip movement of a person. Basically, why we need to do this dubbing means in India, streaming services are going very high. It's gonna touch 100 billion in 2022 because of the craze. Everyone adapted to watch movies, some random series. Everyone these days are seeing all these things. So in order to maintain the quality of the video, we need to dub some characters in that movie or some parts of the movie, so that we are using this technique in order to make the sorry what we say in order to make the characters to be more accurate. So we are doing this project in order to do that actions. We are using some techniques which is called LibGAN. We have an existing architecture which is a LibGAN framework, which we use in order to make the uh, in order to make the lip movement of a person to be accurate.
Coming to LibGAN, this is a framework. This uses GANs. GANs are called generative adversarial networks, in which there is a generator and a discriminator. Coming to the generator, this generator takes the audio spectrogram and video frames as an input, which are both encoded using both audio encoder and the face encoder, and they are coupled together, which is given to the face decoder as an input, which generates a lip synced image. This image is then evaluated by the discriminator, which is already pre-trained with the original audio spectrogram, which gives us the contrastive loss. This can be used to uh, find the difference between the original audio frame and the lip synced image. But this has some disadvantages, which are Narsi, continue.
Actually, when we are developing this LibGAN, where we get contrast loss is very low for most of the models, because when we gave the audio spectrum to the encoder and the generator phase, which we are giving to phase generator, for most of the random frames, it gives contrast loss as low for most of the cases. So that's why it has 56% accuracy. Means it has very less accuracy in finding correct finding the accurate movement of the lip. So in order to overcome that, we are using another framework called Wave to Lip, which was a proposed system which we are proposing right now.
Yeah. So this is a proposed system where we use more accurate lip sync network, and which has a which we also use this new. We just introduce a new benchmarks here, and also this is a first speaker independent model to generate videos. So how it's gonna work? Well, we have our wave to lip architecture. Gonna just move the slide. Yeah. So what are the advantages in the first place? Well, here we're gonna introduce this new pre-trained expert, which is a classifier, which is already pre-trained. That means weights are freezed, and we're gonna use visual quality loss. This is a discriminator where the weights are not fixed. That means this is going to be trained with our wave to lip network. So what's the structure? Well, first we're going to have this MEL spectrogram, which is the input to our audio encoder, and also we have this ground truth frames, which will be the input decoder. So what's going to be the input for this decoder? Well, we will choose the 5 random frames from the given set, and also the 5 ground truth frames with the bottom up masked, and we will concatenate both this together for the decoder, which will be the input which will be the input for the encoder, and we're going to concatenate this into the latent space of MEL spectrogram encoder output of the video encoder output. So these both will be concatenated together for the decoder, which will be upscaled using upscaling or a deconvolution. So we'll get the generator outputs, outputs the predicted frames. What we're going to do is we're going to do L1 construction loss with our generated frames, and the ground truth frames, which will be input to our pre-trained lip sync expert. This lip sync expert, which is a classifier, going to take this ground truth Mel spectrogram input and these generated frames input to calculate the lip sync loss, which will be back propagated while training. And also the same, the generated frames will be input to our discriminator with the ground truth frames in order to classify whether it's true, it's real or fake, and this is going to improve the visual quality. And as this whole network gets trained, the generated output frames of the generator increases their visual quality, and also using the pre-trained lip sync expert, that loss which will be back propagated to a generator with the LLM construction loss increases the lip sync. That's how we have to live this method model in in our Colab environment. Yeah, that's it.
Thank you.
That's it, bro.